Hello, viewers. In today's session, we are going to discuss another important problem from integrals. And in this class, we are going to evaluate this integral that is from 0 to 1. And we have x raised to 5 divided by the cube root of 1 minus x cube. Right? So we'll evaluate this integral with the help of the concept of beta and gamma functions. Right? And before applying the concept of beta and gamma functions, will make use of the method of substitution, right? So let us start. So here we'll try to convert this integral into a beta function which is defined by beta m comma n is equal to 0 to 1, and we have t raised to m minus 1, 1 minus t raised to n minus 1 dt, where m and n are greater than 0. So the purpose of applying the method of substitution is to convert or to reduce this integral into this form, right? So here let us first take this integral as I, and let us make this substitution, that is t is equal to x cube, so that we have x is equal to t raised to 1 over 3. Now let us differentiate x with respect to t to get the value of dx. So we have dx over dt, that is equal to d by dt of t raised to 1 over 3, and using the power rule here, that is d by dt of t raised to n is given by nt n minus 1. So we have 1 over 3 t raised to 1 over 3 minus 1. So we have 1 over 3 t raised to 1 minus 3 over 3, that is 1 over 3 t raised to minus 2 by 3. So we can now write dx is equal to 1 over 3 t raised to minus 2 by 3 dt. Now here the limits of integration vary from 0 to 1. So when x is equal to 0, which is the lower limit, the value of t can be obtained from this relation. So we have t is equal to 0 cube, that is 0. And when x is equal to 1, which is the upper limit, so we have t is equal to 1 cube, that is equal to 1, right? So now we can write this integral I in terms of t as 0 to 1. The limits remains the same, and x raised to 5. So x is t raised to 1 over 3. So we can now write 1 over 3 raised to 5, and then we have cube root of 1 minus t, and for dx we can now write 1 over 3 t raised to minus 2 by 3 and dt. So now let us simplify or rearrange this integrand, and we can take 1 over 3 outside the integral. We have 0 to 1 t raised to 5 over 3, and then we have here t raised to minus 2 by 3. So we can use the laws of exponents to add these two numbers. So we have plus minus 2 by 3, and in the denominator we can now write 1 minus t raised to that is 1 over 3, because this is cube root of 1 minus t, and here we have dt. So now I is equal to 1 over 3, 0 to 1, and t raised to this is 5 minus 2, 3, and 3 over 3 is 1. So here we have 1, and then we have 1 minus t raised to 1 over 3 dt. Now we can write 1 over 3, 0 to 1, t raised to 1, and we can take 1 minus t raised to 1 by 3 to the numerator. We have 1 minus t raised to minus 1 by 3, and here we have dt. So now we can write 1 over 3 Here we have 0 to 1, and t raised to 1 can be written as m minus 1. So we can write simply 2 minus 1, because 2 minus 1 is 1. And here we have minus 1 over 3, and minus 1 over 3 can be written as 2 by 3 minus 1. So now this integral is of this form, and here the exponents, that is 1 is equal to 2 minus 1, and minus 1 over 3 is 2 by 3 minus 1, because 2 by 3 minus 1 is 2 minus 3 over 3, that is minus 1 over 3, right? So now if we compare this integral with this one, then the value of m is 2, this is 2, and the value of n is 2 by 3, and obviously 2 and 2 by 3 are greater than 0. So we can now write I is equal to 1 over 3 beta function, that is beta of m comma n. M is 2 and n is 2 by 3. So now to get the value of beta 2 comma 2 by 3, will make use of this important result, which connects the beta function with gamma function. So beta m comma n is given by gamma n divided by gamma m plus n. Now we can write here 1 over 3, and using this result we have gamma 2, then gamma 2 over 3 divided by gamma 2 plus 2 by 3. So the value of the integral I can now be written as 1 over 3. Now gamma 2 is given by simply 1, because we know that gamma n plus 1 is equal to n factorial, where n is a positive integer, right? So gamma 2 can be written as 1 plus 1, that is equal to 1 factorial, that is simply 1. So gamma 2 is equal to 1, and we'll keep this term as such, that is gamma 2 by 3, and in the denominator we have gamma 8 over 3, right? Now let us find out the value of gamma 8 over 3 using this result, that is gamma n plus 1 is equal to n times gamma n, right? So this is another important result. Gamma n plus 1 is equal to n times gamma n, where n is some fraction here. So we can now write uh, here we have a positive fraction, that is 8 over 3. So 8 over 3 can be written as 5 over 3 plus 1, that is of the form gamma n plus 1. So here n is a positive fraction, that is 5 over 3. So we can apply this rule. So we have 5 over 3 gamma 5 over 3. Now further 5 over 3 can be written as 2 over 3 plus 1. Now again this term is similar to this one, n plus 1, and again n is a positive fraction, that is 2 by 3. So we have 5 over 3, and applying this rule we have 2 over 3 gamma 2 over 3, right? So this is 5 times 2 is 10, 3 times 3 is 9, and gamma 2 over 3. So now substituting this value of gamma 8 over 3 as 10 over 3 times gamma 2 over 3 in this expression, I is now equal to 1 over 3. This is 1, and we have simply gamma 2 over 3, and this is 10 over 9 gamma 2 over 3. Now these two terms get cancelled, and we are left with 1 over 3 times here we have in the denominator 10 over 3. So taking 9 to the numerator, we have 9 over 10. So this is 3 times 3 9, that is 3 over 10. So viewers, the value of this integral I is equal to 3 over 10, which can also be written as 0.3. So the value of this integral is 0.3 or 3 over 10.